If you want to understand the concept of TTL, you have to first understand what are the hops. Well, in this small network, when a packet has to go from point A to point B, it goes through these routers, and these routers are called as hops. Just remember that for now. But the question is, what is a TTL? Well, TTL, or time to live value, is actually one of the fields in an IP header. Now this value is the maximum number of hops the packet can go through before it is expired. Simply said, it is like a packet says. This value is checked by the routers, and if they see a packet with TTL value of 0, that means the packet has expired, so they just discard it. But the question is, how does the packet gets expired in the first place? Well, when the packet is crafted, it has a default value of either 64 or 128. Now this default value depends upon the operating system that is making the packet. These are some common initial values that you are going to find. Now when the packet is sent, each hop router will decrement the TTL value by just 1. So by the time packet reaches the destination, its value is reduced. Now you can check this TTL value using a ping command. In this example, when a packet reaches the destination of 1.1.1.1, its value is dropped to 58, which means the packet has to go through 64 minus 58, 6 different routers, and at the 7th router it was the 1.1.1.1. You can further verify this by running a traceroute command. You can see the 7 different routers that a packet has to go through. By the way, TTL value can only be reduced by such devices that can modify the IP headers, and such devices are layer 3 device. The common example is router. A router is a layer 3 device. So a switch cannot make changes to the TTL value because it is a layer 2 device and it literally cannot see the layer 3 details. Similarly, a multi-layer switch, which can work as both layer 2 and layer 3, if it is routing, it will decrease the TTL value. Otherwise, while just switching, the TTL value is unchanged. TTL values can prevent infinite packet loops in a network. These loops can be a result of bad configuration. But since the router performed these checks, the expired packet gets removed, thus reducing the chaos of the network. So now you understand why it is used and how does it work. Now let's have a look at TTL from a security perspective. If you are receiving some unknown packets, by seeing the TTL value, you can make a guess of what the operating system the sender might be using. But keep in mind that TTL value can often be faked. Network scanning tool like Nmap can manipulate TTL values while scanning the network. So if you see many packets with unusual TTL values, it means there could be someone trying to scan out your network. Finding a packet with inconsistent TTL values could also mean a spoofed packets, often crafted by malware or zombie bots. And these botnets often have a predictable TTL values since they all follow the similar configuration. As you can see, in security, every detail matters, and you can make out more points if you just overthink on this topic. But for this video, I'll stop now. If you love going into depths of small topics, you may want to subscribe to ByteByte. Subscribe and I'll see you in the next session.